Hey guys, Mr. Backwork here. In this video, we're going to look at the product rule with negative exponents. So just a reminder, the product rule says that when we're multiplying things together that have exponents on them, as long as they have the exact same base, what we're going to do is keep the base exactly the same, but we're going to add those exponents together. The only change that we're making today is that we're throwing some negative numbers in there as part of our exponents. And we're going to have a rule that tells us how to deal with those negative exponents. So here we've got a squared times a to the negative third. So based on what we just saw with our product rule, it says that as long as this base is the same, which it is because we're dealing with a's on both of these, we keep the base exactly the same, but we want to add those exponents together. So 2 plus negative 3 is negative 1. Now, we don't typically like to leave our answer with negative exponents in it. So here's what we're going to do. I actually want to think about this a to the negative first as being a fraction. So really, this is over 1. Anytime we have a negative exponent, what we want to do is take that base with that exponent, and we're going to move it down to the bottom of the fraction. But when we do that, the exponent becomes a positive value. So that's going to become a with a first power on it. Now, we still need something on top of the fraction. And technically, in front of this a, there's always an implied 1. We haven't moved that 1 at all, so it's still on top of the fraction. So right now we have 1 over a to the first power. And having that first power on that a, we don't need to leave a power of 1 on a base. So we could really just write this as 1 over a. Now looking at our next example here, y to the negative third times y to the fifth power. Again, we're going to use that product rule, which says keep the base the same. So both of these are base y. So my answer is going to be base y. If I add those exponents together, negative 3 plus 5 gives me 2. Now that's already a positive power, so I don't need to worry about making any changes with it like we did on the previous one. Taking a look at our next example, we've got p times p to the negative eighth times p squared. Now notice there's not an exponent on that first p, and anytime there's not an exponent up there, that means there's an implied 1. So we're going to look at this and we're going to use our product rule since we're multiplying all of these together. These are all base p, so our answer is going to be base p. We want to take and add all of those exponents together. So if we take 1 plus negative 8 plus 2, we're going to end up getting negative 5. So we have p to the negative fifth power. But again, we don't want to leave our answer with negative exponents in it. So I'm going to think about this as being a fraction, so it's over 1. I'm going to take that base of p and move it down to the bottom of the fraction. But when we do, that negative power turns into a positive power. The number out in front of this p right now is a 1, so the top of my fraction stays as a 1. So we get an answer of 1 over p to the fifth power. Looking at our next one, x to the fourth times x to the negative third. Again, these have the same bases, so we're going to leave the base the same. We're going to add those exponents together, so 4 plus negative 3 is 1. So we get x to the first power. Now this one doesn't have a negative exponent, so we don't have to worry about making any changes to it. But typically we don't like to leave a power of 1 on things, so we can just rewrite this as being x for our final answer. Now this next example is maybe a little bit more involved because now I've thrown some numbers in front of those variables. We're going to use the commutative property here as we're multiplying these things together. So we've got 2x squared times 3x to the negative sixth. The commutative property says that I'm allowed to rearrange the multiplication that's happening in here. So what I'm going to look at doing is dealing with those numbers first. So I'm going to take the 2 times the 3, and then I'll worry about the variables later on. So if I take 2 times 3, that's going to give me 6. Now if I multiply these variables together, these are both base x, so I'm going to leave that as a base x. If we take the powers, the product property says that we're supposed to add those powers together. So 2 plus negative 6 is negative 4. Now we don't like to leave negative exponents as part of our answer, but we're going to have to be a little careful this time because of that extra 6 out in front. So I want to think about this as a fraction, so I'm going to put it over 1. The negative exponent is technically only on the x. So the x is the only thing that we're going to worry about moving. We're going to move that x down to the bottom of the fraction. That negative 4 power is going to turn into a positive 4 power when we do that. and the number in front, that 6, stays on top of the fraction. So this is going to end up being 6 over x to the positive 4th power. For our last example, now we have 2 separate variables in there that we're dealing with, but I'm still going to use the commutative property to rearrange things so that I have the like things right next to each other. So I'm going to rewrite this as negative 7 times 3. Then I'm going to deal with those a variables, so a to the negative 4th times a. There's no power on this one, so I'm going to write it as a first power. And then we've got those b variables to deal with. So b to the 5th power and b to the negative 6th power. Now dealing with those numbers, negative 7 times 3 is negative 21. If I look at those a's and adding those powers together, negative 4 plus 1 gives me a to the negative 3rd power. And then if I look at those b's, b to the 5th times b to the negative 6, if I add those exponents together, I get b to the negative 1st power. So we have negative 21, a to the negative 3rd, and b to the negative 1st. I want to think about this as a fraction. Now that a has a negative power on it, so we're going to move the a down to the bottom. And when we do that, that negative 3 becomes a positive 3. The b also has a negative power on it, so I want to move it down to the bottom of the fraction as well. That's a negative 1 power, so when we move it down to the bottom, it becomes a positive 1 power, but we don't have to put the 1 exponent on the b. Now this 21 that we had out in front doesn't have a negative power on it, so we're not moving it at all. It stays on top of the fraction. So for our final answer, we get negative 21 over a to the 3rd and b. That's going to be it for this video. Thanks for watching.